Bana odaklanıyor musun? Bazı şakaları mikrofonu doğru yapıyor.
Alright, the 17th problem in the same exercise sheet. Because there's a subject, there's a section that says subspaces associated with matrices, something like that. Okay? You have row space, column space, row rank, column rank associated with these, and solution space of a matrix. Bunların özetinde videoda geçtik. Well, unfortunately, I have to say something. The summary videos are in Turkish. And I don't trust myself if I can write subtitles in English or not. We will see. So, 17, it says you have a matrix. Okay, the first thing to say is a basis for AX equals 0. This 0 is not the scalar 0. This 0 is the matrix 0, right? The n by n matrix, whatever n is. N by n, n by 1 matrix. Okay, to multiply A by X, what should X's dimension be? Bu X kaça kaç matris? This is a 2 by 3 matrix. So this X is 3 by 1. In general, it asks you for column matrices. So it is a 3 by 1 matrix. So this 0 is a 3 by 1 matrix. No, it's 2 by 1. I'm sorry. Okay. 2 by 1, 0 matrix. Because this is 2 by 3. Okay? So finding a basis for the solution space. For solution space of whatever. I didn't write the problem info. Okay, I want to, actually, the thing I need to do is I want to find the solution set of this thing. The solution set is a subspace. Prove it. Solution set is a subspace of the vector space of matrices of dimension 3 by 1. Okay? 3'e 1 matrisler içinde bunu çözen şeyler diye tanımladığımız şey. So the set that X is in R3 by 1 where X equals 0 is a subspace. Good. How can you prove? If you multiply A by X and you get 0, if you multiply A by C times X, you get 0. If AX equals 0 and AY equals 0, since matrix multiplication distributes over matrix addition, A times X plus Y is 0. That's it. So this is a subspace. It is not empty, obviously, because if you take X to be 0, 0, 0, it is a solution, which means the solution spaces of homogeneous systems. Non-homogeneous systems do not give you subspaces, never give you subspaces, okay? If this is non-zero, 0 is not a solution, meaning you don't have a subspace. It is just a solution set. So homogeneous systems give you subspaces. How do you do that? You just find those x's, right? So solve the system. 1, 1, 1, 1 minus 1, minus 1, x1, x2, x3 to be equal to 0, 0. That's it. How do you solve this? You know how to solve this, right? You take the coefficient matrix, which is given to you, and reduce it, and then find conditions on x1, x2, and x3 to be the solution of this system. So I take A, and I reduce it. How do I reduce it? I take the first row and subtract it from the second row. This is the end of it, right? This will be a pivot, this will be a pivot. So if you like, we can do it a little more. 1, 1, 1, 0, 1, 1, and then 1, 0, 0, 0, 1, 1. The row reduced echelon form will be this, right? Yaptım. Here I don't care what scalar I do, whatever, because this is a homogeneous system. So this will be the last vision of your coefficients, which means x1 should be 0. Doğru muyum? So x1 should be 0 and x2 plus x3 should be 0. Right? Read this matrix. Because ax equals 0 has the same solution set as if this is b, bx equals 0. Bunları yaptık değil mi geçen sefer? Geçen sınav için yapmıştık. Bx equals 0 gives you these solutions. Which means x2 depends on x3 by this linearly depends on x3, right? So one of them will be a free variable, x1 for sure will be 0, and one of these will be something and the other one will be minus. Okay, that's it. So the solution space, solution set, let's say, will be 0, x2 and minus x2. Where x2 runs through all reals, which means x2 times 0, 1, minus 1, where x2 runs over all real numbers. So yeah, this one is the basis. That's it. This is of dimension 1. If you have one free variable, your solution space is of dimension 1. If you have two free variables, it will be of dimension 2. Okay? So there is only one free variable. It means all the vectors in this set are scalar multiples of just one vector. Right? So this is the subspace spanned by 0, 1, minus 1. So the set consisting of 0, 1, minus 1 is a basis. Basis will be 0, 1, minus. Alright, see, this has only one element. If someone asks you to find a basis and if you stop here or here, this is not a basis. This is the whole space, the whole subspace. Okay? This is not a basis. This is a basis. Bunları unutmayın. Alright, there are no finite vector spaces over the real numbers. If you have real numbers, the only finite vector space is the zero space. The vector space that consists of 0 only. It is a subspace, it is finite, but other than this, you cannot have finite vector spaces. So if someone asks you for some subspace, you should not write something like this. Okay? This is not a subspace. This is a basis for a subspace, which means that subspace consists of all scalar multiples of this vector. Okay? Meaning all linear combinations of this set. Since the set has only one element, it means scalar multiples of that element. Okay. Çok serbestsiniz orada. Eksi alsam da ne olacaktı bilmiyorum yani. Eksi bir olurdu, bir şey değişmez. O bunun eksi katı. The thing here is, the question was, why did you take x2 as the free variable? I liked it, that's it. I like it beginning with positive 1. So if you take x3 to be your free variable, you will have 0, minus 1, 1 by x3. It does not mean anything actually, because if you have a subspace that is spanned by a vector alpha, all scalar multiples of alpha also span this one. They are the same. Right? If this is a basis, another basis is 0, 3, minus 3. Right? This is a basis. 0, pi minus pi is a basis for this solution space. Because when you multiply it by 1 over pi, which is a non-zero scalar, you get this one. Right? You can generate each other from one another. Right? Bunu söyledik. Koordinat dedik, matrix linear dependence. Buraya çok düşmeyeyim linear dependence'a. Çünkü niye? Transition matrix örneği yapmam lazım değil mi? Nerede o örnek? Bu. EC change of coordinate matrix. Buldum. Problem 20. B 1 minus 0, 1 minus 1, 0. Find change of coordinates matrices from C to B and from B to C. If we find the matrix from C to B, we can find the matrix from B to C also. Okay, the first question is, show that this is a basis of R cubed. Okay, this is a subset of R cubed. And it asks me to show that this is a basis of R cubed. How do I show this? Well, the thing is, I know the dimension of this guy, right? Because I know this standard basis, so that the dimension of R cubed is 3. Wherever you go, in everywhere, if you take a field, and if you take the cross product of the field by itself n times, the dimension is n. Okay? And this is the standard basis there. So, since the dimension is 3, showing either that this B spans R cubed, or you can show that this B is linearly independent. Every single one of these ways shows you that this is a basis. İster span ettiğini gösterin, ister şeyi gösterin. Linearly independent olduğunu gösterin. Tamam mı? İkisi aynı kapıya çıkar. Çünkü dimension'ı biliyorum. 3 tane vektör var. If I had 2 vectors here, I would be sure that it could not be a basis. Or if I had 4 vectors, I would be sure that it cannot be a basis because the dimension is 3. No more than 3 elements can be linearly independent. No less than 3 elements can span your space. Okay? If you're in R cubed, if you have 2 vectors, it will give you a plane. Okay, they span a plane, so you cannot span all R cubed. So I have this basis. To show that it is a basis, okay, I will use the fact that it spans R cubed so that I can see the coordinates of everything. I will show you 2 things in one step. So, let A, B, C in R cubed and find coordinates of A, B, C according to this basis to understand that it spans everything, right? If for any A, B, C, you can find some 3 scalars that a linear combination of these 3 gives you this A, B, C, it means these 3 span R cubed, right? Span ne demek? Üretmek demek. Lineer kombinasyonlarla üretmek demek. Eğer bana verilen rastgele bir ABC için ben koordinat bulabiliyorsam, yani bunu C1 ile çarpayım, bunu C2 ile çarpayım filan, o zaman bu ABC'yi aha buluyorum diyebiliyorsam span ediyor demek. So when this spans R cubed, I know that it is a basis because there are 3 vectors. Okay? So how do I do this? Solve. Call these beta 1, beta 2 and beta 3. Burası çok küçük oldu. Solve the system C1 mı değil, X1 değil. Or take any X, Y, Z from R cube X, Y, Z and solve A times beta 1 plus B times beta 2 plus C times beta 3 equals X, Y, Z. If I solve this system, if I say that given any X, Y, Z, I can find A, B, C according to X, Y, Z, of course. If I can find those, if they exist, it means these guys span it. And it will also tell me what the coordinates are. Let's see it here. So what does that system give me? A times the first component plus B times the first component of beta 2 plus C times the first component of beta 3 will give me X, right? So the system is then zero times A plus 0 times B plus C equals C. Well, this could be the easiest system I've ever seen. Alright, so from here I understand that C equals D. From here, I cannot understand anything. Okay, so simplify these. A plus B equals X, A minus B equals Y, and C equals D. Well, I have my C, so I will concentrate on A and B. If I add these up and take half of it, it is A, right? From these two, A equals X plus Y over 2, and B equals X minus Y over 2. Am I right? Oh, doğru mu bu? Çok hızlı konuşuyor, çok yoruluyorum ya. So this means whatever X, Y, Z you give me, I can find A, B, and C so that the linear combination of vectors in B can generate this X, Y, Z to me. Okay? So this system tells you that the coordinates of X, Y, Z in B are neymiş? X plus Y over 2, X minus Y over 2, and Z. So this actually means if you multiply 110 by X plus Y over 2 and do it accordingly and add them up, you get the vector X, Y, Z for any X, Y, Z. So this B spans R. This is not enough. Spanning is not enough since B has 3 elements and dimension of R cubed is 3, or you could say the number of elements in B equals the dimension of R3. B is a basis of R3. And you can tell me the coordinates of 1, 0, 0, for example, now. The coordinates of 1, 0, 0 under B is 1 over 2, 1 over 2, 0. Right? So if you add beta 1 and beta 2 and take the half of it, you get the vector 1, 0, 0. Right? Span etmenin ne demek olduğunu hissedin diye yırtınıyorum şu an. Oldu mu? Hissettiniz mi? Biraz daha düşünün. Muhakkak hissedeceksiniz. Peki, what was the question? The transition matrix from C to B. What does a transition matrix mean? It means, alright, you have a basis here, I have a basis there. You have all the coordinates for every vector. I have all the coordinates for every vector, but according to my basis, right? I want to find some way so that whenever you give me your coordinates, I should understand which vector you're talking about according to my basis, okay? So, the coordinates of a vector, according to C to B, right? According to B, should be obtained by multiplying it by an invertible matrix, multiplied by the coordinate in C. This is the transition matrix from C to B. Never underestimate definitions, okay? Whenever you forget about this definition, whenever you don't think on this definition, you confuse everything, okay? They ask you the transition matrix from C to B, you give them the transition matrix from B to C, okay? This happened a lot. Please don't do it. Don't fall for it. Just keep in your mind that the transition matrix means changing your coordinates from one basis to another basis. Okay? It should give you all the coordinates. So what does this mean? I gave the summary of it in whatever, but this P, let me tell you, consists of the columns of coordinates of things in C converted to coordinates of things in B. So, C'deki şeyleri alacağım. The vectors in C are called E1, E2, E3, right? So take the coordinates of E1 in B, E2 in B, and E3 in B. Whatever. I want to go from C to B. I will take each vector from C in order These should be ordered bases, okay? I take the vectors from C, look at the coordinates in B, because this is what I want to go to, okay? And then write them into the columns, because coordinates are column matrices, okay? That's it. Tell me this matrix. You know E1, and you know coordinates of any vector, right? So you can use this to understand the coordinates of E1. What are they? 1 over 2, 1 over 2, 0, right? Here, as we said. 1 over 2, 1 over 2, 0. For E2, tell me the coordinates of E2.
Minus 1 over 2.
And E3?
0, 0, 1.
Muhteşem. That's it. Okay? This is the transition matrix from D to C. D,
C to B.
C to B. Well, we have proved somewhere, maybe you have not seen it, but somewhere people have proved that there is an invertible matrix. It is unique with respect to B and C. That makes the transition from one to the other. Okay, this is invertible. So if you multiply by P inverse from the left side, what you see will be what? P inverse. The coordinates in B will equal the coordinates in C. Right? Come on. Or I can directly tell the inverse of this matrix to use. How do I do that? Let us go from B to C immediately. From B to C. P inverse actually will be, but you can name it some other thing. You can say, you can call this Q, it doesn't matter. Well, what was I doing? I'm going from B to C. I will take the vectors from B and look at the coordinates in C, right? What are the coordinates of this vector in C? Thank God this is the standard basis, okay? The coordinates of 1, 1, 0 in the standard basis are 1, 1, 0. That's it. 1, 1, 0, 1, minus 1, 0, 0, 0, 1. Well, who knows? This is the inverse of this matrix, P. That's it. Okay? I didn't need to find or calculate the entries of the inverse matrix. I know by heart that if you go from B to C by the matrix P, you come back to